There we go. All right, this is Math 335. Where's Lauren? She's my date tracker. I think it's day 12.
Yeah, day 12.
And we're doing prep work for 10.5 through 10.7. 10.5 is on graphing quadratic equations. I'm not zoomed out enough, am I? Thank you. Is it too bright? That's too dark. Ten point six has some problem, like real world examples. We're gonna do a couple real quick. Like doing a whole section on it, it's kind of a lot of time. But we'll take a look at it in the main class. And 10.7 has polynomial and rational inequalities. Now, we're not going to do a lot of graphing, but we'll look at graphs of them using Desmos when we do 10.7. But in here, we're going to touch on the skills that we need in there. So 10.5, looking at it real quick, we've got graphing quadratics. So we'll have like f of x equals ax squared plus bx plus c. The easiest way to graph this is to find the intercepts, find the x-intercept and y-intercept, which we've done before. And find the vertex. And this is actually accomplished fairly easily by completing the square, but kind of like in a special way. So we're going to start with that because we've done completing the square, but it was the more complicated thing. What we're going for when we do it is we're going to get this written as f of x equals a times x minus h squared plus k. Now h and k are going to have different values than the a, b, and c. And in main class, we'll figure out what it is. But this gives us the vertex is at hk. And we're going to do this hk thing a lot for circles, for ellipses, for hyperbolas throughout the semester. The HK thing is pretty handy. It means different things for different problems, but it's kind of like center. For most graphs, it's the center. So let's take a look at doing some practice. Let's say f of x equals x squared plus 10x plus 24. And we want to make it look like this form up here. So how this differs a little bit from completing the square is in completing the square, we move the 24 to the other side. Here, we're not going to do that. We're just going to make some space. We're going to put it to the side. And then anything we add on this side, we're going to subtract. That way, there's a net of 0. Like if I add 10 on the left, I want to, or on the right, I want to subtract 10 on the right also. That way I haven't changed it. But now we can focus on doing the completing the square. So I'm going to bring the 10 down. Remember, we multiply by 1/2 or divide by 2, and we square it.
25.
It'll be 25, right? So I am adding 25 in here. And since I've added 25, I'm going to subtract 25. So we have a net change of 0. That's the only real difference from how we've done completing the square in the past. We still have, this still drops in right here as +5 squared. And now we'll just do this to find out what's at the end.
So is that our answer then?
Yeah.
Okay.
Well, that's the completed the square thing.
So we're not.
Well, remember, we're trying to graph here. So we're not gonna do the graphing in here, but that's our answer for now. If we want to pull the vertex out of it, the vertex, if I look at these two lines right here, that line and that line. Oops, it rolled. Here this says -h, here this says plus. So we're gonna do the opposite. We're trying to get HK. But HK here is the opposite sign of the number on the inside, so it's gonna be -5. And it's gonna be the same, K is on the outside. So that's like -h here, and this is K. K is -1.
We did that after we complete the squares.
Yes.
Okay.
Let me give you guys one to try. And then we'll do a harder one. That's the beauty of in-class practice. So try to complete the square without moving sides. I'll give you a few minutes to do it, and then we'll do it together. How's everyone doing? Anyone need more time? You good? Alberto, Sarah?
Good.
All right, let's do it. What'd you guys get?
-3, -16.
You got what?
For the vertex or
That'll work.
for the vertex, I got -3, -16.
So that means you must have gotten x plus 3 squared minus 16.
Yes,
Okay. Did you get that? Keith?
I got it, +3 and then. Fourth, +3, -1.
Positive 3 and negative 9/4? So that would be x plus 3 squared minus 9/4. I don't know which one it is. So we're gonna find out. Anybody get something different? All right, let's take a look at it. I'm gonna peel off that 7 and just move it to the side.
Vertex.
Yeah, we're gonna rewrite in the form with the vertex. So what we're gonna do is we're gonna take that and we're gonna chop it in half and we're gonna square it. So 6 divided by 2 is 3. This is 3 squared, which equals 9. I add 9 on the inside to complete the square. And to balance it out, I'm gonna subtract 9. So it looks like Jackie's gonna end up with the correct answer here.
I think where I messed up is I wrote the 2 on the bottom and I forgot to subtract, that's where I did wrong.
Yeah, you might, if you squared it before just doing the 6 divided by 2, you're gonna end up with a 4 on bottom. And that would explain where you got the 4. It's all right. That's why we do this stuff in here, get some practice. And so the vertex, I'll put the form up here again, it's ax minus h squared plus k. Gives us the vertex of hk. So it's the opposite sign of what's on the inside. And the same side as the thing that's afterwards. So that looks golden. All right, so Jackie's feeling confident. Can't have that.
yes, I can.
Well, you can, but I'm about to fucking just take that stomp on that shit.
No, I had my Wheaties today, so nothing can bring me down, so.
Well, that's what you say, and then I throw a number in front of the X.
Oh, damn it.
Yep, there it is. That's what I'm looking for.
That's not.
Okay. Fine. Show us your trick so I can do the next one.
Okay, so,
Are you gonna work it out or no?
well, I'm gonna start you on the process.
Okay, I'm gonna say, wait a minute, I don't even know.
Cause like when we did this before, we divided through by it.
Right.
We divided through by the -2.
Oh,
We're going to do something similar. Let me strip off the -2. And I'm gonna put x squared plus 12x. I'm gonna leave a gap. And I'm gonna have my +5. Now to strip off the -2, wait, I'm gonna leave the -2 in here.
wait, you need to keep the -2 or not keep the
Well, you'll see. I'm gonna divide divide by -2. I have the -2 on the outside. This is effectively canceling out and doing the -2 on the outside.
Wait,
So rather than dividing by 2 everywhere, we're just gonna divide by the -2 on the inside.
okay.
That way we can factor out a -2 on the outside. You'll notice that I still like, if I pull the -2 on bottom out, this looks like -2 over -2. Which is just 1, so I'm really just multiplying by, like I started with. -2x squared plus 12x. And I'm gonna multiply it by -2 over -2. But then I'm gonna move the -2 on bottom in.
Oh, for the whole thing, okay.
And that's how I get that.
So we're still keeping the -2 on the outside.
We're gonna still keep it on the outside. We're not gonna complete the square, we're just gonna rewrite what that looks like here. This is gonna look like x squared minus 6x. And I still got plus 5. There's one more hiccup, but let's see what you guys do. Let's see what you guys figure out. Remember, whatever we add, we have to subtract. Let's see who intuits. Is that even a word? Intuits? Like the verb form of intuitive? I don't know. Who figures out what the sneaky bit is here?
The negatives.
Doing the same strategy about we're completing the square. And then whatever you add on the left or on the right, you subtract on the right.
The -6 and -7 and -2.
Oh, no, I haven't finished it. But that's your verdict?
Yeah,
All right. Everybody else is still working. I don't know if that's right or not. Let's see,
Are we having to divide the -2 again? Like towards the end or no?
no.
So the -2 just stays as is?
Yeah, we're gonna end up with -2 times something squared. With something here, I don't know if it's positive or negative yet.
My vertex is positive 3, -1.
And you're getting 3, -4. Anybody else got something different? Give one more minute. What is that thing we're adding on the inside? No. So what have I added to this side? I have not added 9.
With the 5, right?
Well, what do I need to do over here?
Subtract 1.
It is not -9.
Length.
Is it negative?
I have not added 9 to the right side. I added run 9 inside the parentheses. But what I've added to the right side is not 9. We have a -2 out front.
It's a -18.
So I have effectively added -18. So we are going to subtract -18. When we do that, we'll have x minus 3 in here. But we're gonna have 5 plus 18 is plus 23. That was the sneaky part, right?
Yes.
Does everyone see that? That -2 didn't just like, it affects the 9, because if I were to distribute. If I distribute, I have -2x squared. Minus or plus 12x minus 18 plus 5. And if I want to make sure I start up in the same form up here. Like this should equal the same thing. This matches, this matches. But for this, the 5 matches. So I need to compensate for negative 18. So I compensate for negative 18 by adding negative 8 or adding 18. So if you distribute the negative 2, you'll see like actually how it's changed.
So it only changes like that full bus number,
Yeah,
in order for you to see what you do.
Yeah. If you've done this part correctly, factoring out the number, these should be fine.
Right,
All you really need to do is take this and multiply it by what you added on the inside. And that tells you what you've added overall.
wait, and so you said because you give this a negative, you have to add 18 on the other side because we have a negative on the inside?
Well, it's not only, it's we have a total that we've changed it by negative 18. This is from the original, this is from the original, this is from the original.
Right,
This is what we did to the inside
right,
after the negative 2.
okay,
We have to counteract that. So this counteracts the change. And that's the same thing as doing the minus negative 18.
okay. That makes sense.
But rather than multiplying it all out and doing this, just like multiply the thing you added times the thing in front and go, I need to do the opposite.
Yeah.
In fact, it can't hurt if you wanted to. I'm gonna pull this line down here real quick. If you add 9 in here, put out here minus negative 2 times 9. Because then you're duplicating what you had.
Okay,
You guys want another one like that?
yeah.
I thought you might.
I
Jackie likes these things. She's
think I do,
sick.
sometimes.
I don't want to give one that I'm going to do in lectures, so let's try this. I know they were doing giant threads today. I saw them out there when I pulled up. I'm like, well, damn, I would have let the students know.
And you gotta go to that building though. They have a building.
Yeah, but they also have the threads like trailer right outside. Or at least it was an hour ago.
I think it's,
Like I could see suits hanging up.
really? Oh, like jackets?
Yeah,
Oh. Those turds. That's what I don't know.
they brought out common sizes, I think, out here. Like if you need something different, they'd probably set up an appointment for the other place, but. They might just set up an appointment to bring out sizes for you. I don't know.
I went over there and they were like, we're still adjusting to the new space, we don't have everything in, like.
Okay.
That's
21st, I think.
first.
I'll have a practice exam out next week.
My first, I thought it was pretty.
Yeah.
Says the 19th.
But that was, I think, where it started. The syllabus has been adjusted.
Yeah, I think, yeah, it's good. But on the calendar, it's still the 31st. Okay. How many questions?
Generally around 20. Again, I haven't made it, so. So it was. March 21st.
So we don't, like, I know we come in for the exam, but it's not like a lecture day, so we're done with the exam.
Yeah, you can leave if you're done early.
What if,
I like how you think that's gonna happen.
Yeah, I think it's-
What's up, Dave?
what about AAC? If we're corresponding with AAC, how does that?
If you've given me the paperwork, good. If you haven't. Get it to me before, like, next week or so. And you have to make the appointment with them for that day.
I think I've gotten them.
I could check on my too, yeah, I thought it was like the first.
And I just gotta remember to send them the test. But I think there's enough students in here that are gonna do it that I shouldn't forget. Someone's gonna fucking nag me. I mean, remind me pleasantly.
You're welcome.
Alright, so. I'm gonna. Separate this out. Now, this step you could speed up when you're comfortable doing it, but like in terms of lecturing, I don't want to do it. I want to show it. So we're gonna take it, we're gonna chop that bitch in half, and then we're gonna square it. And that gives us a +4. So I want to subtract -3 times the +4. Because that's what I've added. I've added -3 times +4. So I'm going to subtract -3 times +4, which is -12. So this cleans up to this thing in the middle is what goes in the parentheses, -2. And I got -2 minus 12 is -14. So my vertex is,
Yeah. -2.
yeah,
-12.
+12, which makes this
-10.
+10.
Positive.
+10.
So vertex is 210?
-210. Oh, no.
Which one? Is it negative or positive?
Positive, because we have the negative inside.
It's the opposite sign, so +2.
Let me try another one.
We'll do more of those in the next section. I want to do a little splash from 10.7. Because like everybody's like, oh my gosh, this is hard. And no, oh my gosh, no, it's not. So let me go grab a splash from it real quick. And we're gonna go with just the hardest topic in there and do an example like that. Because they're not much different, and if we do the hardest topic, then the easy topics are easier. So when we have rational inequalities, this is gonna be from 10.7. Scroll down and get to a problem. Jesus. Scroll, scroll, scroll. Oh my gosh, fucking scroll on the right. There we go. That's much quicker. Let's start off with one that looks factored. So rational inequalities. Polynomial inequalities is the easier form of this, so we're gonna start with the harder one. It's the exact same steps for everything, except rational has one more bonus step. So we're gonna do like x minus 7 times x plus 2. I'm gonna have everything factored already. Then we'll do like x plus 5 and x minus 1. And we'll say this is greater than or equal to 0. We want to find regions this is true. Regions or number ranges where this is true. So what we do is we find, first off, find everywhere that makes the top and bottom 0. And include them on a number line. The way we're going to include them though is very specific. The bottom is always hollow points. Because the bottom can never equal 0. And that's what we're finding is where they equal 0. So these values, they don't work. But they are important for the next step. And for the top one, we will make solid points if it is got the greater than or equal to or less than or equal to. And they'll be hollow if it's strictly greater or strictly less than. The solid points are only for where there's equality. So what values make this 0 on top? 7 and -2, right? What about bottom?
Oh, no, sorry, +1, -1.
Does everyone agree with that? All right, so. I'm gonna put them on a number line on the next page, because we want room to write underneath them. So -5 is the most left, then -2, then 1, then 7. I'm gonna do my solid points right now on 7 and -2. And I'm gonna do my hollow points right away on -5 and 1. That way I don't forget later on what's going on. Okay, so assuming we picked these numbers correct, and I agree that we did. This breaks this up into a bunch of regions. And in each region, picking a random number from the region, maybe 3 there, 0 here, -3 here, -10 here, and we'll go with +10 over here. Picking any number formed in this region, when you plug it in, is either gonna make it positive or negative, and that applies to the whole region. So if you figure out what sign it is for like one number, it's true for any number in that region. The easiest way to do it quickly is to plug them into this and just figure out what each sign is individually. So I'm gonna rewrite that thing up above. Down below so we can see it a little bit easier as a reminder. And I'll show the 0 category first, because it's the easiest one to show. I am plugging in the 0, and you have 0 minus 7, 0 plus 2, 0 plus 5, 0 minus 1. What these numbers are do not matter. Do not waste your time calculating the overall value. You're just trying to see if it's positive or negative. So the only thing that matters is the sign. 0 minus 7 is negative. 0 plus 2 is positive. These are easy to do with the 0. Because like you get just regular with the 0 and it's negative 7, positive 2, positive 5, and negative 1. When you're using other numbers though, like sometimes it's just like, which number is bigger, use that sign. That really what it boils down to. Which number is bigger? For parentheses, use that sign. So this region has a negative, a positive, and a negative. And remember, every 2 negatives cancel out and make a positive. The overall sign for this entire region is positive. I said greater than or equal to 0 because what we end up with is important later on. Does that make sense what I did?
Yeah,
What part doesn't make sense, James?
Why is there negative, positive, positive, negative? Like I understand it's from those, but why does that make that positive?
Because I'm multiplying a negative number times a positive number, which is negative.
Okay.
Then I'm dividing by a negative number here, which makes it positive.
Okay, gotcha.
Are we good now?
Yeah.
Okay, that was the,
But why is it different in each section? Is it different like where 3 is or 10 is? They're all different?
generally, they're all different. Sometimes neighboring regions are the same. But usually there's criteria that end up making that happen. But usually they alternate. And we're gonna check them. So I'm gonna do, we'll start on the left. I'm gonna do negative 10 minus 7, negative 10 plus 2, negative 10 plus 5, negative 10 minus 1. Bigger number in every category is the negative. Negative, 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 negative. I've got 4 negatives. This region is positive. It doesn't matter that negative 10 minus 7 is negative 17. I don't need to multiply it by negative 8 that we get from negative 10 plus 2. I don't need to divide it by negative 11. And I don't need to divide it by negative 5. What I get for that number is positive. It doesn't matter if it's 1,000 or 0.5. As long as it's greater than 0, that's all we give a fuck about. Does that make sense?
And you go through each number to solve each section.
Yeah.
of This problem. So
If it helps you, write down the numbers each time. I'm not doing negative 10, I'm doing negative 3 here. Negative 3 plus 2. Negative 3 plus 5. Negative 3 minus 1. The bigger number here is a 7, it's negative. The bigger number here is negative 3, it's positive or negative. The bigger number here is 5, it's positive. And the bigger number here is the 3, it's negative. So I have a negative, 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 positive. This region is negative.
that means that all y values are gonna be below the.
All y values will be less than 0. Yes. So negative regions, all y values are less than 0. And positive regions, they're all y values are greater than 0. We'll throw this on Desmo afterwards and look at the graph and see that whatever we come up with should be true. Why don't you guys do the 3 and the 10 here? I chose 3 and 10 just to have the same numbers, but you don't. As long as the number's somewhere in there. You can pick 1.2 if you're a psychopath. But like picking a number that's in the middle and preferably a whole number makes this easier. Sometimes you can't. Sometimes it's like, pick a number between 1 and 2. Well, I gotta go with like 1.5 or something like that. You can't, you're gonna end up with a decimal sometimes. And I'll start coding this up. I'm off screen. No one told me.
This kind of graph, where there's a positive intersection. X-axis. Is that condition under more intervals past these or not? These are the only 4 intervals.
These will be the only spots where they potentially change.
Those mark.
These values are called critical values. -5, -2, 1, and 7 call critical numbers or values. It's where the sign can change. Can. And doesn't necessarily change. I'll do example in the main class there, it doesn't. And you'll be like, huh? Get the fuck out of here. So I got a couple minutes left, I'll plug them in. I'm doing 3 minus 7, 3 plus 2. 3 plus 5, 3 minus 1. I've got a negative, a positive, a positive, a positive. Negative, positive, positive, positive is a negative region. Finally, I plug in 10. Let's change color so it's a little bit easier to read than a wall of parentheses. 10 minus 7, 10 plus 2. 10 plus 5, 10 minus 1. These are all positive. This region is positive. You guys get that? All right, so we want the regions that line up with that. Match greater than or equal to 0. So matching regions would be the positive regions. So I'm looking at, I put it back down here, that region. I'm looking at that region. And I'm looking at that region. When we do that in the interval notation, we start at negative infinity. We go up to -5, but we don't include it, so it's parentheses. We start again at +2, so we're going to do the union sign. And we include, or not +2, -2. Since we include -2, we're going to use the bracket. And we're going up to +1, but we don't include the 1. And then we start up again at 7 and we include the 7, so we're going to use a bracket. Oh, you dirty motherfucker. While we're doing that, while this is repowering, we're gonna look at the Desmos thing real quick. So I graphed it here. And if I throw in the bottom generates asymptotes, lines that can't be crossed. You'll see we said negative infinity to -5 was positive, which means it's above the x-axis because y equals 0 here. Then we said from -2 up to 1, it was positive. And then we said from 7 onward, it was positive. So what we did matches what the graph does. You'll see how to graph that way, like it's one of the last chapters we're doing. Ooh, that's too big. Does that make sense? Now, all it did, it told us which regions were above the x-axis and which regions are below. Later on, it's I don't know. Let me figure out what section it is. I'll pull it up on our textbook. It is chapter 14. Chapter 14, we're going to graph polynomials and graph rational functions. The important thing to remember about the rational ones is where there's a denominator. Denominator can never equal 0, so those are always hollow points. The top can, so it matches the sign. So rational inequalities. Bottom is always hollow. Top matches the inequality. When we have a polynomial, there is no bottom. There's no fraction, which means all critical points match the inequality. They're either all going to be solid or they're all going to be negative. We'll do that for like a whole hour. Polynomial and rational. I think I like starting with the rational. I think if I start with the polynomial, even though it's the easier way, it's easy to forget what happens with the rational. I think if we start with the hard one and it gets easier from there, it'll be easier to remember the rules. And I'm gonna hit stop recording because we have exceeded our time.